Hello, good afternoon, everyone. Hope you are having an awesome OCP summit going so far. We at Microsoft have been using PCIe add-in cards with accelerator GPUs. And here's the case study that we'll be discussing in this session based on the advantages and disadvantages of using PCIe cassette in the server design, which will be in a modular concept. And I'll present you what we have done in our previous projects and what we are looking forward for the future projects to come. So I am Mohammad Tanveer Alam. I'm one of the engineers at Microsoft. I have with me Jason Adrian, Senior Director at Microsoft, and Nanda Kishore, my colleague, who is one of the principal engineer at Microsoft. So let's go deep dive into the topic. So what we'll be discussing in this session will be advantages and disadvantages of server chassis having PCIe Cassette Modular Design for GPUs especially, as well as accelerator cards moving forward. So in the current future and the current design and future design, what we'll have seen is the PCIe add-in cards either is in PCIe slots, and these are more often top-loaded or using riser for interconnect. So these have been in case of all the FPGA cards that we have developed, also the GPU cards that we are currently shipping with, or also some of the other PCIe accelerator cards that we have been working on. So now as we are progressing, we are seeing that we need more GPUs in the server box, as well as the accelerator cards moving forward for all our server design moving forward. And the challenges that we are currently having is these accelerator cards or GPU cards with higher TDP values, which currently we had previously less than 500, are crossing that boundary of 500 watt values in TDP or TBP. So we are facing thermal challenges for these GPU cards or accelerator cards, and we are looking for solutions moving forward. From what we have when we see all these GPU cards and we are shipping at scale, we have to take into consideration what will be DC operations with all these GPU cards. So serviceability of these PCIe add-in cards, whether a GPU PCIe add-in or accelerator cards, are a big challenge for our DC ops. And we want to give them for some solution moving forward. As we are discussing all these challenges, the latest one that we have is the hot plug and easy service of these GPU cards. With the current server design, there's no way or not feasible to have these hot plug or easy service for the current chassis design that we have. So we are looking for solutions in there. And to address all these challenges that we have seen with the design, we came up with a concept of PCIe Cassette Modular Design. We used this concept in one of our shipping projects, which we have used PCIe GPU card. So the challenges that we went through was all these GPU cards or accelerator cards were in the slot. There was no hot plug or easy service facilitated in the current server design. So we came up with the solution in one of the shipping projects called Ratchet. And in here, what we have is the GPU in a cassette format. So for this, what we started was the idea of having easy, quick service and the front loading of the GPU for all the GPU cards that we were shipping with. So what we have seen and what advantages we have seen with this one was very quick for our DC ops operations to service these GPUs. This has significantly improved from the thermal and mechanical for the GPU module that we have used. Basically, we have the thermal solution for the cassette itself. That has significantly improved the overall thermal of the node that we have, because there are some fans that are particularly for the GPU card, as well as the fan at the back for the full service for the server itself. Now, we were looked into a hot plug feature. With this design, there is capability of adding hot plug enabling that we were looking into more details, and we can enable the hot plug functionality with this cassette modular design moving forward. Here, what you see in the picture is we have the horizontal cassette that we are shipping with. This is the GPU card primarily focused for all the gaming SKUs, for VDI, and also for rendering. So this is available from one of the Microsoft Azure VM offering that is currently available for the customers. Now, with this cassette design that we are moving forward, we have different thermal solution that we can go with. For GPUs less than 300, so current one was a 300-watt card, which we can easily cool with the air solution that we have from the fans at the back of the GPUs. And with the improvement, what we have seen is with this design moving forward, we will be adding a density to the chassis and the server design. So we will have more if we either use in a vertical format or in the horizontal format moving forward. So I have Nanda, who can cover some part of the hot plug functionality that we were looking into more details. And we can enable that using this cassette design. Go ahead.
Hey, thanks, Tanveer. So from the hot plug capability side, so there are like a couple of options, right? So one is the informed removal or the managed removal, and the other one is the surprise hot plug, right? So here we were looking at options like how we can do an informed or a managed removal. So if we have mechanisms on the tray where we can actually give an attention button. So when an attention button is pressed, so it basically indicates to the operating system that, hey, this device needs to be taken out. So it doesn't cause any downstream port containment or anything. So it just is a very informed removal. So it tells, and it basically takes the device off from the PCI bus, and it can be easily serviced by a technician. And the other way is, like, if in the real environment, if the operating system sees that a particular hardware is which is connected to the cassette is tending to fail because of a lot of correctable errors, then the operating system can take action to bring the device down by making by writing to the slot control register or the power control bit to be turned off, and then take the device, right, and then assert the burst. That way we can basically hot service the device, right? In this case, GPU device or any other device for that matter, right? Whichever we put in the cassette module. So that way the hot plug makes it easier and easy to service in the cassette module. Yep. Thanks, Tanveer.
Thanks, Nanda. So moving forward, what we have seen using this PCIe Cassette Modular Design, there are a lot of advantages moving forward. And as we are in the arena of AI, where more concentration of GPUs are going in the servers, whether in PCI add-in cards or OEM form factor. So this is something which for PCI add-in, a cassette format can be very beneficial. So what we are looking for in the future designs is the advantages part, especially the quick, easy service, even with the hot plug enabled cassette modular design for PCI add-in cards, concentration on GPUs as well as the accelerator cards. That includes the other FPGA cards that we are shipping with. So we had in the booth Mount Shasta that gives you an idea of the cassette that we are currently using. So I'd like Jason to give a little more details about what we did in Mount Shasta.
Sure thing. So you saw examples earlier when you start putting one GPU in a box, but when you start going higher, other accelerator cards, you have to think about how you package it inside the actual system. Because again, time is money. You already mentioned about riser cards and packing things in. That just doesn't scale, especially when you're doing tens of thousands, hundreds of thousands. Time is money. So going to the more vertical form factor, putting them in the front, easily hot accessible. Obviously the mechanical part, you can see some examples out there. We'll continue to evolve that. The electrical part, the operating system hooks, that's going to continue to evolve as well. But it's an exciting time for us. You're going to start seeing density become more important because accelerators may get larger, higher power. They may get smaller, and we may put a lot of them in there. But regardless, they have to be serviceable, and it has to be quick and easy.
Thank you, Jason. So as you just heard that we are looking into solutions that can enable these PCI cassette in the vertical format for higher density. Now, come the challenge that we will see, and this is where we want the industry and the contributors to come in, is the challenges and we will face is with GPUs with higher TDPs crossing the boundary of 600 watt, what kind of thermal solution we will be looking into. So the solution is right what we discussed in OCP this far, that liquid cooling is the way to go, as well as how you want to do it, right? So we are looking into solutions of liquid cooling through cold plate. There are talks that are already there with the blind mate connectors that we have seen. So the future design, we want to incorporate these type of available resources from our contributors to use this and facilitate for this solution where we can enable these PCI cassette moving forward. So with these cassettes, we definitely will hit what we have seen from the issues from the past, which was the GPU cards and accelerator cards in the top-loaded riser cards in the chassis server. The higher TDP cards can be addressed with all these thermal solution that we have currently that ranges from air-cooled with fan dedicated for the cassette to the liquid cool with the cold plate solution that is available right now. And with these PCI cassettes that we'll see, what we can do is we can cater the needs of different PCI add-in cards, which form factor they come in, right? So one of the cards, whether it's a PCIe CEM full height, full length, full height, half length, what are form factors that we can cater the needs of that particular card with the cassette designed for that particular application. So this will open the opportunity of doing a cassette design that can be used common throughout all the PCI devices, PCI add-ins that we have been using or will use in the future. And answer to that one will be whether it's horizontal or vertical or one or two or three, whatever the addressing needs will be. So beside that, what we will have seen, this will, as the density increases and the power number goes there will be some advantages that we will come across seeking this PCI cassette. For say more GPUs with higher TDPs, you have to design auxiliary power for these cards. So basically, there will be some more additional help needed to facilitate these cassettes. And there will be other need for that. And we'll look into more details. That for liquid cooling, if we facilitate with hot plug, what kind of solution in terms of addressing the dripless solution for these cassettes will be. And looking into more detail, how the DC operations can handle that, right? So at the end, when we ship these cards, whether they're 100, thousands, or crossing that boundary, how the DC ops operation team will be handling these cards if these are there for the liquid cooling as well as the hot plug or hot plug enabled. So there are many advantages and of these modular design of using PCI cassettes that we can go through. The call to action for this session is we need participation from all the connectors, liquid cooling solutions that are available in the market, as well as giving us feedback of what you see and how we can improve this cassette modular design and what else we can add. We are addressing the need of acceleration and GPUs. Can we use it for storage? This is a challenge, right? So there are many solutions that we can come in, and we can portray how we want to use these cassettes. So contribution to the OCP market space with all these components that will be available for cassette. And also to do a mezzanine card mailing list. So if you have questions, please post there. We'll try to address and collaborate there well. So by this, I open the next for a discussion. If you have any questions, we are happy to answer that. Jason, you want to add some last notes for this?
Let's see. I guess the only thing to kind of the bigger call to action is that this isn't the first time the industry has gone down this path. There are challenges, physical and electrical. We're going to continue to find more of these things over time. So yeah, get involved when you see opportunities. These are the type of things that make a lot of sense to standardize. We can solve it together. Question.
Hey, this is Paul Kapler. I spend a lot of time thinking about the NIC specifications. What are the connector? What do you think about your pinout in the back compared to what's going on in EDSF? What's going on in OCP NIC? And how does what you're doing compare to all that? Maybe I missed that, or just good to talk about?
So we intentionally left that ambiguous in this presentation because it could be when you have a cassette, you're not tied to a particular connector. From the card, you could choose what to plug into a cassette, and then we can standardize or pick maybe a different type of connector, backplane cabled, to go into the system. But within the cassette, you could have PCIe CEM, you could have a custom form factor, you could have multiple devices that plug into maybe a centralized board. There's a lot of flexibility when you go into a cassette-style architecture. You're giving it power, you're giving it space, and you're giving it some amount of PCIe. How you innovate within that, lots of options.
Same with the thermal connectors, then you're not going to standardize that either. You're just, your water, for example, or whatever.
That one is a little bit different. So if you look at a lot of the QDs that you see and a lot of the blind mate, they're typically meant for high flow rate to cool very large thermal loads. Here, that's a little more scaled down, so that would be an opportunity to standardize and drive some commonality. So yes.
We'll look forward to seeing how we standardize that.
So if no more questions, thanks everyone for attending this session and looking forward for more collaborations with this PCI cassette modular design. Thank you.